problem is based on the projectile motion. Okay. From the top of a tall building, a gun is fired. The bullet leaves the gun at a speed of 350 meters per second, parallel to the ground. As the drawing shows, the bullet puts a hole in a window of another building and hits the wall that faces the window. If the vertical drop from the hole in the window to the wall is 0.45 meters and the horizontal distance from the window to the wall is 6 meters, find the distance h in meters, find the distance d in meters. Okay, let us try to understand the problem. Here what is happening? Here is the gun and then the gun fires the bullet. The bullet has the initial velocity of 350 meters per second. This is the x direction velocity. Okay. This is VIX. Okay. Let it be 1. And then here, one more thing you should remember. When it is starting with an initial velocity of 350 meters, this is along the horizontal direction. Along the vertical direction, the velocity is 0. Vertical component of the initial velocity is 0, but the horizontal component of velocity is 350 meters. That you should remember. Okay. And then now we have to find out the other component to calculate the D and capital D and H. We have to find out the time of flight and also the initial velocity. Now let us see how to find out the these components, these things. Okay. Now the bullet, what is happening here? Let us see. This is the diagram. Like this, it comes. This is the height h and this is the displacement d. This is equal to 6 and this is equal to 0.45 given to us. Okay, and then the bullet comes like this and then falls like this. Okay, so here we have to find out with what velocity it is coming. So VIY we have to find out here. But here VIY is equal to 0. But here it has some velocity because it is already dropped some height. Okay, that is why it has some velocity here. Y component velocity is here. With this, we have to find out the time of flight and also the initial velocity of here of the bullet while entering into the window. Now let us try to calculate the time of flight of the bullet through the window. That we will find out using the data. This is 6 meters x component, and then this d is equal to vt, we know, therefore t is equal to d by v, and then 6 by 350 gives 0.017 seconds as the time of flight of the bullet through the window. Okay, now we have to find out the initial velocity of the bullet here at this point. So for that we will use the equation delta y is equal to VIT plus half AT square. And then we know delta y is equal to 0.45. And as it is, the bullet is coming down and then falling on the ground. So I will take the h as delta y as negative 0.45. And then I am trying to find out the y component velocity of the bullet and then plug in the time here. And then acceleration is negative of g, that means minus 9.8. When I plug in the values in this equation, I get initial velocity of the bullet while passing through the window is 26.16 meters per second, negative of. Okay, I am getting negative because again the bullet is coming down. Okay, next I have to find out the time of flight of the bullet, entire from here to starting point to coming to the rest. That I will find out using the equation Vf is equal to Va plus At. And then here the final velocity is equal to 0 because the bullet finally comes to rest after hitting the wall. So that therefore Vfy is equal to 0. Therefore 0 is equal to this is the initial velocity just now we found out. And then A is equal to 9.8, negative 9.8, and then time T1. To avoid the confusion, I am putting T1 here. Okay. Total time of flight as T1. Therefore, T1 is equal to 2.669 per seconds is the total time of flight. This is. Now plug in the value in the displacement equation. As we know, displacement is equal to velocity times t. Therefore, 350 times 2.669 gives 934.5 meters. Okay, that is the horizontal displacement of the bullet. Okay, that means the distance between the two buildings are from this building from this building to resting point of the bullet is the 934.5 meters. Now I have to find out the vertical drop of the bullet. How much distance it traveled vertically, because I found out the horizontal one, vertical one I have to find out. For that again I use the equation delta y is equal to V80 plus half at square. But here what I have to do is I have to deduct the window length. While finding the total height of the this one or total displacement along the y direction, I have to deduct the this one because this is the opening, so I have to deduct the y component of the window, or I will call it as length of the window. So here again the bullet is coming down, the distance I am taking the negative. So negative of h minus 0.45 is equal to vi by t plus t1 plus half a t1 square. Here t1 is the time of flight of the bullet. Time of flight of the bullet. Total time of flight of the bullet. Okay. Now VIY is equal to 0 because I told you, initially the y component velocity of the bullet is 0. Only it has x component velocity. It is projected with the x component velocity, not with the y component velocity. And then acceleration is equal to minus 9.8 meters per second square. And when I plug in the values, I will get h as 35.35 meters. Okay. So this is the answer for the question. I hope you understood the intricacies of the problem. Just you should remember that here the time of flight of bullet, and then here it has some velocity while entering into the window, but at the time of projection initially it has 0 initial velocity along the vertical direction. It is projected only with the horizontal velocity initially. That if you remember, it is easy to solve the problem. Okay. Thank you. Bye-bye.